Okay, so for some of you guys are still wondering how do you use the Normalcdf function and why do we use it. So here's an example, hopefully you guys can read it, talking about blood cholesterol for people. And so we're saying for 14-year-old boys, blood cholesterol is actually roughly normal with a mean of 170 and a standard deviation of 30. So I'm asking you that if we know that somebody who has a cholesterol of 240 or higher means that they need medical attention, what percent of 14-year-old boys will need medical attention? So if we drew a normal curve, which I've already drawn, so here it is, mean at 170, so my standard deviation is 30, so my point of inflection is at 30 away. I want to figure out at 240, so right around here, what percent of my boys will fall in there. So I want to know what's the proportion or the probability or the percentage of boys that will have a cholesterol that is greater than 240. So I could go to my table, which would mean I would need to find the z-score for this. With my calculator, with Normalcdf, I don't have to find a z-score. So all I would have to do is do Normalcdf, and then there's four things that go into it. My lower bound, which in this case is 240. My upper bound, since this is continuing, I would say it's going towards infinity, which we write as E99. My mean of my normal curve, which in this case is 170, and then the standard deviation, which here is 30. I would type this into my calculator, and it would give me the area under the curve for that. So again, so it's Normalcdf, 240 to E99, so I press second comma, that's the E that we're using, 99, my mean, which is 170, the standard deviation, which is 30. When I now press enter, this is the area under the curve for the piece that I shaded, so 0.0098. So that means that area is 0.0098. I convert that to a percent, which means that 0.98% of 14-year-old boys would need medical attention. I hope this helps. If you have any questions, please email me.